Hello everyone. Welcome to our course Azure Kubernetes Services or AKS Deep Dive, which covers in depth a deep dive for AKS and Kubernetes. This video is part of this course and will cover Lesson 2 in Module 2, which is Getting Started with Docker. This video is part of Module 2, Understanding and Working with Docker. And this is where the video is located in the current module. So let's start. Module 2, Lesson 2, Getting Started with Docker. This lesson will cover the first. We will start by getting an overview what is Docker and even understand what is the English meaning of Docker based on Cambridge Dictionary. Then we will get an overview about the complete Docker history and all the important stops in the Docker life. Started from the beginning, the origin for the Docker and what was the company and how the company moved forward. Also, what was the first commit in Docker when it was considered as an open source, the first release of Docker and when it's released several editions and many other important stops. Then we will get an overview about Docker editions so we can understand what is the difference between community edition and enterprise and even how these editions evolved over time. And then we will understand the running platforms for Docker. So what are the platforms that Docker can run on them? After that, we will get an overview about Docker features based on main three categories. Then we will get an understand of Docker and the Open Container Initiative, which is a great initiative by Docker company to set standardization around using container runtime and image specification, which will help not only Docker but all companies in the world that are developing containerization software to be based on open standard instead of each company can build their own standard. Then we will get an overview about some of the Docker vocabularies. This including the Docker image, container, registry, and many others. These are few of the vocabularies, and in next lessons we will get more and more about those vocabularies. And then we will get understanding what is the image and containers and what are the difference between them. And after that, we will get in more details and depth about image and container to make sure we understand that very well. Then we will get a simple image and container workflow. This will give us the workflow for how to create a container from an image and what is the container state and many others. Remember, this is a simple image and container workflow. In the next lesson, we have a comprehensive image and container workflow which will cover all the workflow in details. But in this lesson, we will just get the basic now to get the initial understanding. And then we will understand what is the container registry, what is the types of container registry and how we can use them. And then what is the container repository? Also to make sure that we are not confused about container registry and container repository. After that, we will talk about what is the Docker manifest file and how we can use it in the same way that we use the image. And then we will get to understand an overview about the common pitfalls when we working with Docker container or in the container in general. And then we will get to understand what is the Docker architecture and how the Docker working as a client server and how Docker client send the commands using a RESTful API to the Docker server or the Docker daemon. And then we will get an overview about image tag and how and why it is important to use it. Before we start, let me give you a quick introduction about myself. My name is Mohamed Radwan. I'm a developer technologies MVP and principal DevOps consultant. I have been doing software development for more than 17 years now. Worked on several projects for different enterprise customers across different regions and countries. For more info about me, you can review Lesson 1 in Module 1. So let me start from the beginning. What is Docker? In a very simple definition, Docker is a tool chain for building, running, and managing containers. To understand that, let's look at what is a Docker name from the Cambridge Dictionary. So Docker as a noun is a person who works at a port putting goods onto and taking them off ships. So this is the meaning of Docker, and this explains a lot about why Docker Inc. chose this name for naming their software. So when we look at Docker, so Docker is the leading open source containerization platform considered as a container technology, which is working as an engine, which is a utility that can efficiently create, ship, and run container. It provides a uniform wrapper around software packages, which help me to build, ship, and run any app anywhere. And this definition based on docker.com. Similar to shipping containers, the container is always the same regardless of the contents, and this is why it fit in any trucks or ships. And this is the beauty of the container technology. Docker history. So in January 2013, this was the first start with a company called .cloud that provide platform as a service solutions. In January 2013, this was the initial commit in Docker. In March 2013, Docker released as an open source. In March 2013, Docker 0.1.0 released. In September 2013, there is many collaboration from many companies like Red Hat, Fedora, OpenShift, and others. In October 2013, .cloud pivots to Docker Inc. and the headquarters in San Francisco. In March 2014, Docker was the 34th, was one of the top most starred project on GitHub. So we can see that in March 2014, it has more than 18,600 stars on GitHub, 3,800 forks, more than 740 contributors and more, and keeping continue. In 2014, Jack's Innovation Award, which is the most innovative open technology. In March 2017, Docker released Docker Enterprise Edition, merging the previous enterprise offer, which you called in that time the data center, and renaming their free offer to be Docker Community Edition or CE. So let's understand what is the current Docker editions. So we have the Docker Community Edition and the Docker Enterprise Edition. So the Docker Community Edition, this is the free and open source containerization platform. And for the Enterprise Edition, it is the same, but it's just a premium version of the Community Edition. So it has integrated, fully supported, and certified container platform. So while both editions offer the same core features, but Docker Enterprise Editions comes with additional features that can help companies and enterprise to launch, manage, and secure their containers more efficiently. For example, you can gain access to certified Docker images and plugins. You can also receive official same-day support for Docker for any issues that could happen in your applications or in production. You can run vulnerability scans on your Docker images. You can continuously vulnerability monitoring and Docker security scanning, and many other features supported for the Docker Enterprise Editions. For more information, you can visit the Docker Enterprise Edition on docker.com. Running platform. So Docker can run on many platforms. So we can see that it is started by various Linux distributed systems like Ubuntu, Fedora, CentOS, and many others. In October 2014, Microsoft announced to integrate Docker with the next release of Windows Server. This is why it is run natively on Windows Server 2016. Also, there is Docker for desktop for Windows 10 and Mac OS. Even Docker can run on most of the cloud providers like Azure VM, Amazon EC2, Google Computing Engine, Rackspace, and many others. And even Docker support to run on Raspberry Pi. So Docker features. So to understand more about Docker feature, let's have the feature of Docker based on three categories. The first category is the lightweight. So Docker is a very lightweight. So it consumes minimal overhead for CPU, I/O, or network. It's based on Linux container and uses layered file system to save space. Use a copy on write file system to track changes. And this capability, one of the main reasons to have the image layers as we have now. Based on the portability, as we explained before, it can run on Linux based on Linux container. 0.7 release includes support for Red Hat Fedora family. Raspberry Pi support, Docker Desktop for Windows and Mac OS, possible future to support for other and new operating system as well. For self-sufficient, Docker container contains everything it needs to run your application, either the application, the runtime, the libraries, and everything. So it has the minimal base OS, libraries and frameworks, application code. A Docker container should be able to run anywhere that Docker can run, which means you can run your application on all the platform as we explained before, the same way as it is run on any of them. And this is really explain how the Docker containers is changing the way of building and running our applications. So Docker and the Open Container Initiative. So this is very important step that started by Docker Inc., which is in June 2015, Docker and the other leaders container industry kicked this initiative to have open standard for containers technology. And these standards to cover two specifications. The first is the runtime specification, which under this page on GitHub, and the second is the image specification under this page. The important of that now, Docker or any containerization technology company, they will not build or develop the containerization software based on each company standard, but they will be based on open standard that they have for this initiative, which is, from my opinion, this is a game changer as well. Docker leads the pack. Based on the Forrester New Wave Enterprise Container Platform Quarter 4 in 2018 report, which shows that Docker is leading the pack for the containerization platform, and it is well suited for the enterprise. So based on this report by Forrester, the Docker Enterprise is leading container runtime with some capabilities with Kubernetes and Swarm, which give multi-cluster management strong and consistent across many public cloud and on-premises infrastructure platform as well. So when we look at Docker technologies and containers, we can see that the main idea of containers is to have multiple isolated Linux system on a single host. Of course, not all the time it is Linux container because there is Windows container, which means I can have many isolated environment on the same host, which give me ability to isolate several applications or services or microservices on each isolated system. It is based on layered file system. So let's see some of the Docker vocabularies. So Docker image, this is the basis of a Docker container and it represents all your application. So it has all your application and all your application code and runtime and so on. The Docker container, which is the standard unit in which application services exist and executes. The Docker engine, which is the software or the engine that creates, ship, and run Docker container deployable on a physical or virtual. It could be hosted locally or a data center or even in a cloud service provider. The registry service like Docker Hub for public or Docker Trusted for registry in private, it is a cloud or a server-based storage where I can distribute and store my images. So images vs containers. To understand what is the difference between images and container, let's look at the image first. So just imagine this is an example of image from Ubuntu with Node.js and the application code. And you can think of the image is the same as the class. So it is the blueprint of your container, which means that it is a static snapshot that has the operating system and also the runtime, which is the Node.js, and also the application code. And then if I run the image, I will have the container, which is similar to an object from that class, which means that in the running container, which is an instantiate a container from that image, it means that now I'm running my application, including all the runtime, including the application, and I can execute my application inside the container. So again, it is the same idea between class and the object. And with the same idea, I can have multiple objects from the same class, and each object has its own state. So let's look more details on the Docker images. So Docker images is persisted snapshot that can be run. So when it's run, this gives me the container. It's a read-only layer or layers, so I can't change the image because it is read-only with several layers. Docker images don't have state because they are read-only, so there is no state for them. What will have the state is the container because it is the object. It is not a VHD. You can think image is similar to VHD, but it's completely working in a different way. So it is not preferable to say that images is a VHD or very similar to VHD because it is not. It is uses a union file system based on Linux and basically a tar file. When we get for further lessons, we will understand how to transform from file system to tar using Docker export and import command. Has hierarchy because as we explain, first we have the base image, which is layer 0, and then we have several layers that they refer to each other, and the first layer is referred to the base image. Docker image fit into Docker Registry, which we explained before. It's a place where I can store my Docker images. So what is container images in more details? So container image is just a static snapshot of a container configuration that is never modified. Just see this example. This is example of a container based on an image from Ubuntu 14.04 image. So we can see that this container running from an image that has 4 layers. And these 4 layers are read only. So I can't change that. But we explained before that images, they don't have a state because it's read only, but container have a state. So where is the state of the container? This is what we are going to see now. But the container itself, it has a state, and the top layer of the container is read and write. This is why all the changes will be only in this layer, which is not part of any image, but it's just the state of the container. And at any point of time, any changes made to the container which exists in this layer, I can save them by creating a new image layer, which will be created, reference the previous one, and so on. A Docker image is built up from a series of layers. Each layer represents an instruction in the image Docker file. We will get more information about Docker file later and how I can use the Docker file to build an image, and each line in the Docker file will be represented as an image layers. Because each container has its own writable container layer, all the changes are stored in the container layer. Multiple containers can share access to the same underlying image and yet have their own data state. This is why each container, it will has its own data state, and this will not belong to the base image or the image that these containers are created from. Docker containers. So as we explained, Docker containers are just runnable instance of an image. So when you run the image, it gives the container. It gives us the container. So it runs everywhere, regardless of the kernel version, regardless of the host, but container and host architecture must match because again, it shared the kernel or leverage the kernel of the operating system of the host machine. Run anything. If it can run on the host, it can run in the container. If it can run on a Linux kernel, it can run on the container. How containers are launched? So a container is launched by running an image, as we explained. Once you run the image, it gives you the container. An image is just an executable package that includes everything needed to run the application, which is the code, a runtime, libraries, environment variable, and configuration files. So it includes everything to run the application. A container is a runtime instance of an image. What the image becomes in memory when executed, this is what we called the container. A simple image and container workflow. So if we look at, for example, this is a base image based on Ubuntu latest version. If I run this image, now I will have a container, which is container 1 with a specific ID. Let's say ID 1. Now I can change this container, make any changes, and these changes will be only exist in the container 1 which has the ID 1. And all those changes is not exist on the base image on the Ubuntu. If I commit these changes, I will have a new image, which is all about a new layer and all the previous layer, which is referred to the base image that I created the container from it. This is why if I run a new instance from the image 2, which will give me the container 2 with a new ID, this container will include the changes that I committed to the container 1 because I created this container based on the image 2. But of course, if I create another container from the base image, it will not include these changes. So all the new running container from this image will include all these changes. But each new container will have its own state which will not belongs or will not exist in the image that is used to create that container. So what is a container registry? Container registry, in a very simple definition, is just a repository or a place to storing container images. It can be public or private. Private, so it can be within my network and behind the firewall, so no one can access that, or it can be public, like public registries, for example, Docker Hub, which is free for everyone. Private registry on the cloud, like Azure, for example, like Azure Container Registry or AWS or Google, which allow for efficient and secure storage for my image, because container image will include my application, and there is no companies will prefer to store the application on the public registry. So what is the feature or the capabilities of the container registry? First, it's searchable. I can go for the container registry, search for what is the desirable image that I want. Example of private registry like Azure Container Registry. Example of public registry like Docker Hub. And the registry is an open source which is under Apache license on GitHub. So Docker Hub is the public repository for Docker images, searchable for several Docker images, automated, has been automatically built from Docker file. So Docker Hub registry, all the images on the Docker Hub registry are built from Docker files which are exist on a GitHub and the source available on GitHub. What is a container repository? So don't confuse between container registry and container repository. So container repository is a collection of related Docker images that have the same name but labeled with different tags. That indicates the image version. The main idea, just imagine that, for example, Ubuntu 15.04 or Ubuntu latest. So with the combination of the image name and tags, I can have the same image with several versions, which give me the ability so I can have the same image with different versions. Think of it, it is a directory or folder that you will have a several image of your application, but with several versions, because each image will has different version. It is the same image directory, but it is different images because each image has different version of my application. A single repo can contain platform variants such as a Linux image and Windows image. So inside one repo, I can have several images as well. Just imagine if the image is my app version 1 and my app version 2, and my app is version 1 is Ubuntu and my app version 2 is Windows. So it doesn't have to be the same operating system, but I will say it is the same image with different tags, which mean that I can have several images. So it is up to you how you are going to combine the image name and tags to have different images or to maintain versions for images for your applications. What is the Docker manifest? So Docker manifest is the information about an image, such as layers, size, digest. The Docker manifest command also gives the user additional information such as the operating system, the architecture an image was built for. So it gives me more details about the image that I'm using. So the manifest is a list of image layer that is created by specifying one or more, ideally more than one image. It can then be used in the same way as an image name in Docker pull and Docker run command. So instead of run a Docker image, I can run a Docker manifest, which is very similar to an image, but with more details about the Docker images. To simplify that, just think of Docker manifest. It's just a Docker image with more information or with very detailed information. So there are some common pitfalls when we work with Docker. The first, that UI-based application. So all containers run without UI, which we called headless running. So don't expect that you can have RDB or remote desktop protocol for your container because you can't. From the persistent storage, there is no persistent storage strategy for working with container. It doesn't mean that I don't have a persistent storage, but it's not by design. And all what I can have is just some bind, mount, or volumes for the container. So for example, sharing a file with the container host, I can use bind mount. If I want to share files across multiple containers on multiple machines, then this will be the named volumes. For connecting to a remote store like database, for example, if I want to save the persistence state of my application. The second category, no authentication strategy. So Windows containers can't join the domain, but can still use Active Directory domain identities to support various authentication scenarios via group managed services accounts. Resource limits. Unlike the VMs, container can use as much resources as the container host can provide. This is why I must set limits via the CPUs, the memory, storage, and so on. If you set more CPUs or memory than available, Docker will error CPUs or let you create, but not start the container in the memory. From the volume mount volume into clean directories within the container. If you are mounting a volume over an existing directory and you expect to see the files from the existing directory, you won't. So I can't see the file from the existing directory. I will only mount the volume so I can manage that through the containers. And this is the consistent with the behavior of the mount because Docker volume based on the mechanism of Unix file system mounting. Docker architecture work as a client server model. So we have the Docker client and the Docker server or the Docker daemon. Docker use client server architecture. So the Docker clients talk to the Docker daemon, which does the heavy lifting for building, running, and distributing your Docker container. The Docker client and daemons can run on the same system, or you can connect from a Docker client to a remote Docker daemon. The Docker client and daemon communicate using RESTful API over Unix sockets or network interface. So Docker client or Docker CLI. So it is a command line interface that can run or available for Linux, Mac OS, and Windows as well. The Docker client, also known as Docker CLI, it is the primary tool you use to manage Docker containers. You can download container images from repositories such as Docker Hub, build container images, run container instance, list container images and instance, and much more. After connecting to Azure Container Services using SSH, you can use port forwarding to execute command locally that can act on Azure Container Services running on the cloud. So Docker server or Docker daemon, as we explained, it is the Docker server, which a type of a long running program called daemon process. The daemon creates and manages Docker objects such as images, container, network, and volumes. So you're using the Docker client to communicate with the Docker server or the Docker daemon through the RESTful APIs, as we can see. Image tag. So image tag is a string value that you can use to distinguish version of your Docker images. We explained before what is the Docker repository and explain the combination between the image name and the tag, which I can use to have several versions of my images. So we can preserve older copies of variants of primary build. You can group your images together using names and tags. At the end, I would like to thank you for watching this video. If you have any question or inquiry, don't hesitate to reach out. Thank you.